I'm not sure. Well, good afternoon, everybody. I'm just trying to make sure that our screen sharing is occurring, so just bear with us for just a moment. Is this working?
I don't see your screen.
Okay. Okay, hopefully my screen is now working. Can somebody give me a hand?
Yep, I see it.
Oh, that's great, Farhan. Thank you for being here. Thanks, everybody, for being here. My name is Wayne Levin. I'm joined with my friend and colleague, Farhan Mansour. And we're here this afternoon to talk about leveraging machine learning and artificial intelligence and R&D. Oh, is that still sharing? Yeah, it should be.
Yeah,
engineering and science. Terrific. Okay. So I thought what might help is if now it's not letting me advance terribly easily. Okay, first, if I may, let's go through an agenda just so we know what's coming up. We'll talk a little bit about our company, not for very long, just a couple minutes about Predictum, just so you know where we're coming from. We'll then talk about artificial intelligence and machine learning and productivity and knowledge work generally. And when we say knowledge work, we're talking about engineers, scientists, business analysts, and the like. We're then going to get into some demonstrations, and there's two areas of demonstrations that are going to happen here. The first is to begin with the end in mind, which is how are we going to employ, how are we going to exploit the machine learning models? And that's something that we call BuildLAB. So we're going to start there so you can see that happening. And in order for BuildLAB to work, of course, it needs models, and those models are built with machine learning, and that's done with something called BuildLAB. So that'll be the second demonstration, if you will. After that, we'll talk about how you get started in building an application like this. And I'm just going to say now that you know, this is really broadly applicable, but the example we're going to show is for in formulations and compounding, but really it's applicable in pretty much anything. And we'll try and illustrate that as we move forward. And also we'll take questions. So there's a mechanism by which you can ask questions. And if you would, as we're going through, just enter your questions, type them in. And when we get to the end, we'll have a look at those questions and do our best to answer them. All right. So with that, we'll move forward. Predictum. We've been in business now over 27 years. We are an analytics company, and just as it says here, we partner with our clients in engineering, science, and business to improve their knowledge worker productivity and problem solving for smarter operations and superior products. We do it through a multidisciplinary approach that blends programming, engineering, and statistical methods. So this is basically us. We're a group of engineers, statisticians, and programmers. Most of us wear two hats, some of us wear three hats. So while both Farhan and I are both trained engineers, we also do programming. And as you'll see, at least with Farhan, we do statistical work as well. It's kind of the intersection of the three that we refer to as data science. That's how we think of data science. Okay, so enough about us. Let's get into the artificial intelligence and machine learning and productivity and knowledge work. So the goal basically is to improve productivity and knowledge work. I mean, just like in any organization, we're always interested in improving productivity. That's not simply a matter of what happens on a production line, which of course is a lot of focus and productivity, but we think we can improve it as well in knowledge work, and indeed that's what where our work is focused on. So let me just give you a quick look at the end in mind here. this is a profiler, and Farhan's going to show us this. I hope you can see this moving. So what you're seeing along the x-axis, those are factors. Those are things that we control and we can change. And on the y-axis, you see some responses. If, these are material properties that we wish to improve or to set or optimize. And all those lines in there, except for the very right column, that's the model. Or in fact, there's 4 models here. And those models were built using machine learning. And Farhan's going to show us how that's done. So here, what we're doing is we are building these models using machine learning, and we are exploring those models interactively in software, if you will. So this is like a virtual lab, as we're going to discuss and elaborate on shortly. Okay. So what's the method here? Well, you got to build a model. First of all, you got to build, generally, the example you just saw, if you can keep that previous slide in mind, there are 4 models actually there. So we use the machine learning to build these 4 models, and they form, if you will, standard work, or they are a big component of what we call standard work. Now, if you look at any productivity improvement effort in any way, shape, or form, it usually involves some kind of standard or establishing some kind of standards. And I can get into more detail with this if maybe you have some questions about it, but it might be a topic for another day, frankly. But standards facilitate productivity and they facilitate creativity. And let me elaborate. That model that you're seeing over there, it encapsulates and expresses knowledge explicitly. Okay? And if you will, in a sense, it's a standard, but it's not a fixed standard. I want to make clear. It serves as a reference point. Okay, so all of your subject matter experts are referring to this model. And 2 things happen. One, the subject matter experts challenge the models. They look at it and they go, does that make sense? Is that accurate? And on the other hand, the models challenge the subject matter experts because the models are coming from the data. And there's a certain dynamic, and you might even say a certain tension that goes on there. And that's actually a very healthy thing. That's a very productive thing to do. And that it happens with all of your subject matter experts all at once. It's really interesting to be in meetings where we're looking at models together that we produced and, and evaluating them and so on, because people are working collectively to formally, if you will, evaluate the model. So it's not a notion in somebody's head. It's an explicit thing that we're looking at and gives us that common focus. And that's what we like to call collective intelligence. So that's what the models do. That's the kind of role that they play. And actually, again, it's a productivity game changer, in addition to the other level of productivity that we're going to talk about shortly. Okay, so in order to we have, if you will, kind of like 2 product or 2 areas here that we're going to demonstrate. They're related. The first one is building the models. So in order to do that, you have to have data. Now, in the case of formulations and compounding, that data will be some kind of experimental history. Generally speaking, it could be production data as well. And from that history, and Farhan's going to demonstrate this, we're going to produce these statistical models. Now, how do you make those models accessible? What can we do with them? Well, we can do it in simple ways that are very quick, and we can do it in more sophisticated ways. And that's what we're going to show you with SashLab. And you'll see that they're interconnected. You'll see a GUI that shows up. Farhan will demonstrate in just a moment around creating designed experiments and then evaluating those experiments virtually within SashLab. So let's just focus a little bit on that for a couple minutes. And then we'll get to the first demonstration. Okay, so this is what we call SashLab. And our goal in that is, again, to increase productivity in R&D and in problem solving. Here again, the collective intelligence, because we have these explicit models, these explicit expressions of knowledge. And one of the reasons folks do it is to be able to, for example, substitute ingredients. Sometimes there are supply chain constraints or costs that go up. It's quite interesting because we see this in more than one industry. We work in a number of industries, consumer products, chemical, semiconductor, solar, aerospace, all kinds of them. And they actually all, they source raw materials, and sometimes geopolitics gets in the way. But anyway, I'm not going to dabble in that. So here's the traditional experimental workflow, and we want to improve the productivity of this workflow. So a formulator or compounder will come up with some design they want to investigate. They'll submit it for physical lab testing, and then they'll look at the results. Hey, if those results are good, that's wonderful, and they'll go and they'll run off with it. And if not, it's back to the drawing board. The productivity hit is that it's expensive and it takes a long time. And most of that time is just waiting. It's waiting to get that, to get the lab time. Lab's busy, and in any of these projects that we've done, the lab is not, we're not trying to make the lab less busy. What we want to do is make sure that before things get to the lab, the thinking is fully vetted. And that's where SashLab comes in, because what we're able to do is design a formulation, and Farhan's going to show us in just a minute, and then design experiments with it and submit that to SashLab, which is where the machine learning models are going to evaluate the experiments, if you will, and give us quick feedback. So you can do many cycles like this in the course of, an hour or a day or what have you. And then if it looks good there, then submit it to the physical lab. Now you still have to wait, but they're fully vetted, and they're taking advantage of everything that the company knows or has learned, because these models are based on historical data.
Conference will automatically end in 5 minutes.
I don't know why it's telling me that. That's a little scary. It's very cheap to do it this way. Are we all still here? I hope so. Okay, Farhan, do you want to take this over?
Yep.
And
I'll take the screen. Wayne, can you remove your screen share?
That's exactly what I'm trying to do. Okay, it says screen sharing stop, so hopefully you've got it now.
Okay. Let me know when you see my screen.
All right. I'm not sure. I'm seeing your screen here, Farhan. Yeah.
Okay.
And I'm seeing we're getting some questions from the audience. So thank you for that. And
okay, sure. So we'll start. So this is the SashLab interface. So what you are seeing here is the compound editor part of the interface, where you can select formulations or recipes from your database or historical recipes. You can make new recipes and explore that. So what I will do for the demo purpose, I will select a sample recipe and I'll add it to the compound editor. And what it will do is it will basically pull all the ingredients that were part of the recipe and amounts that they were used at. What you can do is you can compare multiple recipes. I can add another recipe and compare it. Also, you can create new recipes. For example, in this demo, I will copy this existing recipe and I will change some of the values of some of the ingredients. Just to show you how it works. So once a user is happy with a new recipe or a new formulation, whatever you want to call it, you can also look at the differences. So the red will highlight any difference in ingredient amounts between two recipes. Now this is helpful when you're comparing multiple recipes, like more than 3-4 recipes. It will be easy to see how those recipes are different. Once you're ready to explore further, what you can do is there's an interface down below where you can look at all the models that are available for exploration. So these models are built by BuildLAB, which I'll demo in a minute or two. So you can select which model you want to explore. So after selecting your models, I selected 3 for this demo: aberration, hardness, and length. You also have these condition parameters in the middle, where you can choose your processing conditions. Let's say if you have those with your data, and these are also incorporated in the models. So you can fine-tune them here. And once you are happy with the conditions and the recipe and the models you want to explore, you can submit to the design editor. And it will basically give you all your predictions for those ingredient amounts.
Right. So this is where the an experiment, if you will, is being done virtually. It's a designed experiment, if you're familiar with design of experiments. We also facilitate informal experimentation that sometimes folks prefer, you know, in given situations. Anyway, go ahead, Farhan.
Yeah, so this is what Wayne was showing earlier. So you get to see the jump profiler here, and it basically lets you fine-tune your ingredient levels that are changing. So I can play with it, and you can see the numbers, the prediction values will change on the y-axis. So the experimenter can see what values will give what properties at various levels. So at the bottom, yeah, go ahead.
Sorry, Farhan, if I may just interject quickly.
Yeah.
This you know, what Farhan's just doing over the course of a couple of minutes, what generally knowledge workers are doing is they're spending quite a bit of time exploring the different levels and then looking at the responses. And they obviously want to optimize across that. Farhan will show us that in just a moment. Sometimes what they'll do is they'll change the experiment. So they'll go back, they'll try a different recipe, they'll add ingredients to an existing recipe. They'll do all kinds of different things to more fully, you know, vet, you know, look at what's available type of thing. And that's what I meant earlier, because one of the things that we're doing here is we're making sure that knowledge workers are taking advantage of what others have learned, what they and others have learned in the past. What they have learned in the past comes from data that's been recorded from previous other production runs, or often from previous experiments. And then they get turned into models, which we'll show you, and then they get viewed in this way. So again, they're looking at this, they're being challenged by the models, and they're challenging the models. Sometimes they'll look at it and they'll say, I don't think that behavior is correct. And then that leads to a cycle of exploring that model further. Perhaps there was a problem in the data, and so on. So anyway, there's just a lot that can go on with this. It doesn't happen in 30 seconds. It usually happens, people will spend a good amount of time going through it. Sorry, Farhan, I hope I didn't break your pace too much here.
No, fine. So what another thing you can do here is you can optimize some of the properties. So what I will do is I will choose some of the optimization features that we have available here. You can maximize a certain property, minimize it, match target. And once you click optimize, it will kind of figure out the values, values of the ingredients that will give the desired conditions for the properties.
Right. As that's going, you can see there's an importance column there, Farhan. So you can rank, you know, which of the properties are most important. It's just a score on any scale you want to give it. And so you could say something's twice as important as something else, and it will you know, optimize accordingly. How did this come out? Actually, pretty good. That desirability number in the lower left there is a number between 0 and 1. And it says, well, if you set these X's at the levels you see, there's a 4.8, a 33 and change, 20, if I'm reading this right, then you'll have a desirability of almost 3/4. Not too bad. And again, this is an area that, you know, people will explore. They might cycle through it several times in order to get that desirability higher. And then at the end of it, they might say, okay, I want to validate this let's go and generate this recipe, send it to the physical lab, and have them test it out and get, if you will, real numbers. Barton, is there anything else we want to show on this particular screen?
No. This is, yeah.
So that's the end in mind. That's where, we're exploiting the models, if you will. You can't do this without the models. So the question then becomes, well, how do we get the models? So that's where I'll just, if I can, I'm going to try and share my screen.
Yep.
Okay, that's a little bit of a challenge here. Okay, this will hopefully only take a second. So let's see. Okay. Sorry, folks, I have to enter a number in order to make this happen, evidently. Whoop. Okie doke. I don't have to spell my name right, but it might be a good idea.
Yeah, something's loading.
Is it coming up?
Yeah, it's loading, so.
Brian, can you tell me when you see it?
I see this. It's finished loading. I don't see your screen yet.
Yeah, it seems to be. It says sharing your screen. It says that I'm sharing. Okay, folks, can you see it? Anybody? Oh, maybe I have to click this button over here or something.
Yeah, in the Join Me click. Yeah, I see it. I see it now.
Thank you. Okie doke. So this is the second part then, the BuildLAB part, which is what we use to create these models. And what we're trying to do is improve productivity there, building these models and updating them. The updating part is very important because when I say standard work, like I said earlier, it doesn't mean that the models are fixed. They're always open to challenge. They have to be kept up to date. For example, in the case of formulations and compounding, there's new ingredients to consider, for example, that come online, and then there's old ones that might be dropped off. And if you're talking something in the financial sector, you might be talking about a new type of promotion or something along those lines, that you need to bring into a model. So updating, again, is a really important thing, but it takes time and energy because modeling really is a trial and error type of thing. There isn't, it's just that. So what happens is, if I can make this happen, is we've got data. The data generally consists of response data, like how many people responded to a promotion, or those physical quality characteristics that are important in some formulation or compound, or it's, if we're talking solar, it would be, how many watts are we getting out of a panel, that type of thing. And of course you have the factor information. So the steps will vary a little bit, but depending on the situation, but sometimes what we have to do is combine sources of data because they don't sit in one place necessarily. We have to do some pre-processing to match the recipes, the factors, if you will, with the test results, the responses. There's normalization that often has to take place. Sometimes we have to segment the data. So these are different things to work on and to try when doing the modeling. So, and that's the next step, the modeling, which is to work with the variant sets of data, but also variant hyperparameters. And Farhan's going to show us this in just a moment. Okay, so that modeling needs to take place, but the idea behind BuildLAB, as you'll see, is that you can sequence it. You can put it together and then say, okay, computers, go to it, go do the work. All right. Now, once the models are done, you need to do some kind of model quality checks. And there are some numbers, Farhan's going to show us some numbers we can look at to help in that area. But of course, the real check is the subject matter expert review. or what I like to call the smell test. You know, does it make sense? Okay, and sometimes it doesn't. And one reason why it may not is because of the arrangement of the data. So we have to go back and start, you know, working on the data. Sometimes there's outliers in there that shouldn't be there, or what have you. So the architecture looks something like this. There's a supervisor machine which is orchestrating the work. So we're creating a list of things to go and do, and that supervisor is passing instructions on to client modeling PCs. So the more PCs you've got, the more work that you can have done in parallel, because you're going to see in the demo that this is going to take about a minute or two, but modeling often takes an hour, 2 hours, 3 hours a day, several days, just depending. So if I have any luck, I'm going to try passing this back over to you, Farhan.
Okay.
And we'll see what BuildLAB looks like.
Let me know if you see my screen.
Oh, mind you, it's a preparing display. Is yours coming up? Okay, it says loading screen share, but is it loading my screen share or your screen share?
It's loading mine.
Okay, good.
Let me know when you see it.
There we go. I see it.
Okay. So here is the kind of the BuildLAB interface that you see right now. So on the left side, we have this supervisor PC that Wayne was showing on the slides. On the right side, you have one of the client PC, which I'll get to in a minute. So in the supervisor PC, the idea is you create your modeling parameters, meaning you play with the node configuration, so penalty methods and things like that. So here on the left, you see the node setup. So what BuildLAB does, it uses JUMP's neural net platform to do the modeling. And so you have this opportunity to kind of choose your node configuration that the neural net will use. And in BuildLAB, what you can do is you can give it a range. For example, if I do it from 0 to 1, so what it will do is the BuildLAB will try to do 2 variations of the modeling, one without Gaussian activation function and one with the Gaussian activation function. So those kind of things you can do right here from the BuildLAB. On the other side, you have this option to choose your penalty methods. So for the demo purpose, I will choose the squared error and the absolute error. So what BuildLAB does, it runs the model once with the squared penalty and another time with the absolute penalty. So also you can play with the number of tours. I will just go with 20 for the demo purpose. I don't want to slow it down too much. And there are a few other things you can do that has to do with your factors. You can limit your factors, which factors you want to include in your model, things like that. You can control it. Once you are kind of happy with how you want to model various combinations, then the BuildLAB will run each combination separately, and you will be able to see the results at the end, where it compares all various model iterations. The idea is kind of trial and error, right? So you're trying various combinations just to figure out which combination of hyperparameters work the best, gives you the best model. So once you're happy with your setup, you can select which data sets you want to model. Right now, I have kind of have 4 data sets for the demo, so I selected all of them. At this point, what you can do is you can add it to modeling queue. So there is a modeling queue that exists in a central location, which all the modeling PCs can connect to. And once this modeling instructions go to that queue, all the modeling PCs will then start doing the modeling work. So what I will do is once I selected the model, once I selected the data sets, I will add it to the queue. So you see the button here. And when I select, when I submit it to the queue, I will show you where it goes. It will, so you can see the queue list right here on the bottom left. So I sent 4 instruction file to the central location. And on the right side, you see the client PC. And as soon as I make it active, it will start acting on the modeling. So I'll make it active by clicking on this run button. And then you can see it's already started modeling. So it will go through each one of them and run all the iterations. And if I update the queue, you'll see the 3 left. If you have more than 1 modeling PCs connected, then each will take one of them, and it will make the modeling task faster. The idea is to distribute the modeling task, because sometimes your data sets are huge and it takes time to do the modeling. So a distributed system helps managing it.
Yeah, this is where the fun happens. The machines get busy, the fans pick up, and it's a little more interesting to watch than a front-loading washing machine. But anyway, actually, this might be a good time to answer one of the questions, which is how self-sufficient can one be with this system? The answer is pretty self-sufficient. You know, the initial sort of work, usually we have to set up, and people with an analytical mind can usually run this on their own. Not, you know, after getting familiar with it and with the concepts involved in doing this machine learning. Anyway, so we'll just let this finish, will we?
Yeah, so it's done.
Yeah.
Now, and I'll show you how the results look like. One second.
Yeah, so Farhan, you're going to one of the result files here?
Yeah, it's not just sharing it. Hold on. Give me 1 second.
Okay, just while Farhan's finding locating that file, a number of files get produced from this, and let me just answer a couple other questions. One is about the columns represented in the 4 models. So when we get a chance, we'll bring that desirability function, the profiler, back up. I think we can better answer that question there. Farhan, did you get where you need to be?
Yeah, I should be here. Do you guys see my screen?
There it is.
Yeah, I don't know what happened. Okay. Okay, so here I ran 4 models. So you see all the result output files. So what it does, it creates this jump tables, which has, I'll open one of them just to show you what it looks like. And so this is the hardness model, and I ran 4 iterations of it. And then it generates all these columns with lots of data. It will tell you what kind of configuration that was used to model it. But the few of the columns that are important are the error values, because you're trying to minimize the errors. So I'll just quickly jump to that. Here you can see the root mean squared error, and the lower the error, the better the model. That's one of the criteria there are many other criteria, but I will just sort it. Point is, you are trying to minimize this error, and you're trying to also make it a stable model. So the BuildLAB idea is, once you run enough iterations, you can figure out which combination minimize the error, and then you can select that model to use with the SashLab. Another important column is the formula column. I'll quickly show you that, where it shows the formula that the neural net model generates for each model iteration. So this is the formula then SashLab uses. So once you finalize a model, once you know that this is the best model, then this formula can be used in SashLab to do the things we did before, the profiler and the predictions.
Okay, very good. Thanks, Farhan.
Yep.
If I may, I'll try. This is one last passing of the screen. Are you going to stop sharing, and I'll try and start sharing? Let's see if that works. Portray display. Yeah, I think it's making me manually go back in each time. So let me just try and get this up. Come on. Okay. Okay, and okay, so hopefully I'm coming back up. Am I there yet? Okay, looks like I am. Can you see me?
Yeah, I can see your screen.
Awesome. Okay, so this is getting started with the last section, and then we'll look at any questions that you've got. There's a couple of others at least that are in the queue, so thank you for that. I'll also put some contact information, and there's also a couple of documents that I'm happy to email to you, so that will help you as well understand this. So building and maintaining, a machine learning system, this is what we do. This is how we make this happen. We start with an initiation and assessment. The key here is evaluating your data. Not everybody has their data in a state that we can work in off the right off the top. Usually, in fact, that's the case. The question is, can we get it into? Can we structure it? Can we work with it? And we need to establish a data security protocol, if you will, so in order to protect your IP. Sometimes we do this work actually on your systems rather than on ours, so that your data doesn't leave your premises, if you will. So we'll build some preliminary models. So we'll use BuildLAB. Once we get that data arranged, or a sufficient amount of that data, it can be a pretty large project. So we'll start with a subset of that, and we'll start building models with it in the fashion that Farhan was just showing you. And then we'll review the models. We won't put it in a SashLab. We'll be able to look at it, though, in the profiler that we were showing you earlier. And then, it's a matter of bringing your subject matter experts and letting them review it. And it's like, hey, do these models make sense? Sometimes you have to go around once or twice here, but, we don't want to sink ourselves into a big effort of building infrastructure if, for whatever reason, your data are just not going to support the modeling. Anyway, so that's the initial part of it, if you will, and we work hand in hand with you in order to bring that about. And then once we've got a preliminary amount working, and you can actually use the models at that point. It may not be in a SashLab, but you can use it. You can use the profiler. But then what we'll do is we'll widen that semi-automated model building. So we'll incorporate more data. We'll look at more response information, and bring it in and really get those machines working. And at the same time, we'll work on customizing SashLab for you. What you saw earlier was kind of a generic example, you might say, in one particular instance for formulations and compounding. For you, it might be something different. So we need to understand what that is and start building that out. Then the next step is to combine the two, basically to bring the models that BuildLAB has built, and Farhan gave you a quick glimpse of what the model looks like, and put it in the SashLab, just incorporate it in SashLab. That part's actually easy. We've already got the code for that. We build around that code. And then to keep it evergreen, it's not an exact representation, but you generally do acquire more data. Over time, like in a formulation compounding situation, as I said earlier, you will add more ingredients, or you'll take some away, and you may be changing your operating conditions, for example, new equipment, things like that. So we need to incorporate those things, the new data, if you will, that comes from that, and update the models. That way you're keeping the models evergreen. And through it all, there's that, again, that challenge that's going on where the models are challenging the subject matter experts, and the subject matter experts are challenging the models, and that collective intelligence is being built. So that's what's happening there. So that's how we began. And I may have answered, I think, one of the questions I had a quick look at least I hope I have. So let me just proceed. Farhan, I am going to throw the ball back at you because I did see one of the other questions. Before I do that, I don't know if anybody wants to just make note of this, and then we'll just get to the questions. If you send an email to ai@predictum.com, that'll come to me or Farhan or one of our colleagues, and we can answer any questions you've got. If you want to talk about your specific situation and how this might work, then the way to start is just to send us an email, and let us, we'll initiate a discussion with you. So to make it easy, I just put ai@predictum.com. And Farhan, if you would, hold on, maybe I can do this, Farhan, and not have to change screens. Because the question had to do with, if I can just bring my way back, this. Just to understand this a little better, because it was one of the questions, I did get a glimpse at it. Each row here, where you see these different numbers, these are models. So each row going across is a model. So we've got 4 models that are used here. So imagine the material, you're trying to achieve a number of different things comprehensively here. So, we're trying to hit a certain abrasion, we're trying to minimize. That's what this slope here means. It's called a desirability function. And here it's saying you're trying to minimize abrasion and you're trying to maximize length. With hardness, a couple of different hardnesses, here it's saying we're trying to achieve a particular target, okay? And so for each of these models going across, all right, we have the same X factors that are involved. And what you see sliding back and forward is just moving those X's back and forward manually. And the red numbers here are predicted values. They're actually predicted averages. So n predicted samples at a particular setting will have an average of those levels, if you will. And you can see the desirability is going up and down as we're moving things back and forward. What Farhan did earlier was he clicked the button that said optimize. And what it did was it looked at the profile of the desirability functions. Buried behind it is importance. And it tries to maximize this number. So it'll come back with settings, if you will, that maximize desirability. So that's what's happening here. I hope I've answered that question. If I may, I'm just going to stop sharing and look at the interface here and just see what other questions there are. If I can manage that. Okay. Let's see what else we've got. There was a question about Jump Public here. Those models could be deployed using Jump Public or Jump Live. That's up to you. But that's something that we are looking at. When I say it's up to you, I mean we would not want to take your models and put them out over the internet. But that's certainly something that that you can do. Let's see if there are some other questions here. Yeah, the question about what type of professional service do you provide getting the team up and running with this tool? Well, as I described, there is that initiation and assessment, and we're working very closely with you in order to make that happen. But usually what happens is as things kind of settle, you can manage pretty well on your own, but we're there to provide support. So both in terms of the application itself, SashLab and BuildLAB, but also as consulting work, if you will, on machine learning and so on. So if you have some people who are interested in learning about it, then this is a good way for them to learn machine learning. They don't need to, well, they have a tool, if you will, to work with. So through it, they'll be able to pick it up pretty well. And like I said, we're there to support them. Just seeing what other questions we have. Here's one about neural fit. There was Farhan. This one would be for you. During the simulation, neural fit came up in the profiler.
Yeah, so it's a nonlinear. Yeah, it's just nonlinear modeling. So we're trying to fit. Now, usually we avoid fitting like to the 3rd degree or 4th degree. We filter those models out using a various filter test that happens after we build the models in BuildLAB. If that's the question. If I got the question correct.
Okay. If you want to ask a supplemental question, we're looking at the, if you want to type something in, please go ahead and do so. The question came up earlier about or 25 years or whatever achievements. In terms of this, it's quite interesting. We've tried to get some numbers from our clients, and what kind of numbers are you getting? What kind of return on investment are you getting? It's really very difficult to calculate because, frankly, it's actually quite high. One client told us that it was a 1,700% return on investment simply on the number of experiments that are being done virtually. And they were saying if we could possibly do those experiments live, it would cost a fortune, to make that happen. But of course, they can't do it because the constraint on that is the lab. Others have told us that because the modeling has allows the experiments to be fully vetted before it gets to the lab. What happens after the lab? Well, usually after the lab, it goes to another level where they're doing some kind of a product build, if you will, because formulation or a compound is on a component level. So they will do some kind of a build after that. And a bad build is a big waste of money. So we've been told that that they've definitely seen a reduction in the number of wasted builds, if you will. In some cases, have gone down to pretty much, have gone down substantially. Let's put it that way. So that's another way of gauging this. How can you gauge the benefit of, building that collective intelligence where everybody together is challenging the models and being challenged by it? What happens is like they converge. Everybody's converging on, and hopefully on the truth, and ultimately that truth is continually tested. So it's hard to calculate a return on caring and working with erroneous information or an erroneous understanding of how something behaves. But we've heard that over and over again, where the instances of, we used to think that this was true. The model came back and is telling us it's not true. We challenge it and we validated it, if you will, and we find out, it's not true. It may have been true at one point, but it evidently is no longer true. So it's really hard to put a return on investment on something like that. So anyway, that I hope gives you some idea about what, the kind of improvements you can expect from this. And if you, care to have a conversation, then we can explore what that might mean for you in your particular situation. Does anybody else have any other questions just before we close out here? We do have a few more minutes left. Let me remind you and ask you if you wouldn't mind, I promise you we will not send you spam. We will not put you on some list or anything like that. Rest assured, we have no need of that and not interested in doing that. We all know what kind of nuisance that is. But I would like to send you a couple of documents. These are, if you will, like a data sheet I'm not sure if through BrightTALK we can distribute it without you asking, to be blunt, but we do have a 2-page document on both SashLab and BuildLAB, and it talks about the features and benefits and so on. I'd be happy to forward that off to you. There's another question that just came in. Can we run this in the cloud? But let me finish my comment first. I'm sorry. Just send an email to AI, like artificial intelligence, AI@predictum.com. And predictum is like the word predict with a U as in uniform, M as in mother. AI@predictum.com. My email is levin@predictum.com. Levin is like Kevin, only with an L as in Lima. Can we run this in the cloud, like on AWS? We are doing something here. I'm sorry?
Sorry, Lynn, sorry to interrupt. Yes, I said it runs in Jump right now. As long as there's a setup that you can do on the cloud with Jump, yeah, it can definitely run via cloud. Wayne, do you wanna?
Yeah, just so you know, we've been doing our own comparative analysis of model building with different software. I don't want to say that it was completely exhaustive, but we have looked at open source software and so on. Jump is substantially better. It really came out in front. Just very reliable models, very well produced. Still got to do the trial and error, but also that profiler is a wonderful feature of Jump. One of the things I like to say is that when you use software like this, the subject matter expert should not be thinking about the tool. They should be thinking about their subject matter. And that is true of the profiler. They're moving the factors left and right. They're thinking about those factor levels. They're seeing the responses that they can expect. They're not thinking about the tool. And that's one reason, that's one of the primary reasons that we've built this on a Jump platform. Yeah, the model building does require Jump Pro, but the user does not need Jump Pro. Just the model building, BuildLAB requires Jump Pro. But models produced in Jump Pro can be deployed in the regular version of Jump. For folks who'd like to know. And you can see more about Jump, go to jmp.com. jmp.com. Okay, we're coming up to the top of the hour. If anybody wants to ask anything else, please jump in there, no pun intended. Okay. Well, if that's the case then, I think we can close it off for today. I want to thank you all for your participation. We have a really good number of people from all around the world in a good number of industries, both services and engineering and science, pharmaceutical. So it's terrific to see all that. It's relevant for all of you. And I'll remind you one last time, do send us an email at ai@predictum.com. And we'll get these data sheets, if you will, right out to you. We can do that in the next day or so. Okay. All right. And with that, I think we'll close the presentation. I'm already seeing very nice feedback. Thank you very much, and we really appreciate that. Farhan, thank you as always, and BrightTALK, thank you kindly. Have a good day, everybody, and a good evening wherever you are. Cheers.